Maybe next we could tackle sort of HVAC, since that's the next biggest. Would you agree, the biggest energy hog in any home, really?
Yeah, definitely.
No matter what climate you're in, I think. But yeah, let's tackle HVAC. How you might go about not troubleshooting, but lowering bills or approaching that.
Yeah. So in an existing home that, already, that somebody is already living in, and if they said, let's talk about HVAC, I would say, first of all, just the system itself, how old is the system? And, depending upon the answer to that, if it's, more than 10 years old, I'm using 10 anecdotally. I really don't know if there's data to support that. But I would say if the system is more than 10 years old, there's a high likelihood that a new system would be significantly more efficient. Again, getting back to regulations and technology, the manufacturers are just building better equipment now. And so the return on your investment of, just replacing the system outright with something that's got a higher efficiency because it's newer is kind of an obvious first step. But also, in addition to that, the size of the unit. So you mentioned earlier in this conversation about, having a 3-ton unit in your current home and that it's constantly cycling on and off. Short cycling of HVAC systems it is a real problem. They should not be they should not be doing that. If you realize that your air conditioner is constantly kicking on, kicking off, kicking on, kicking off, then it is probably not sized properly for your home. And what that means is that it's oversized. And so it's blowing this insane amount of cool air into the house and, telling the thermostat very quickly, the house is where it's supposed to be. And then, within 15 minutes, because your home is efficient, is probably inefficient in other ways, your thermostat senses, okay, it's warm again. Now we got to kick it back on, and it's going on and on and on. So getting back to life cycle costs, that's terrible for your system. That constant turning on and off is not good for the life of the system. So that's a concern. And then the comfort, of sitting in a home that is constantly, on and off and on and off is, that lack of consistency doesn't feel good. So also looking at, what is the size of the unit? Is it possible that if you're going to invest in a new system altogether, well, then let's just also take one additional step to evaluate whether or not your 3-ton cooling system could possibly be 2.5, especially now that we're going to get a more efficient system installed. And that helps with the cost of it, right? So when you call an HVAC contractor and say, I'm interested in replacing my unit, it's a 3-ton unit, they're going to assume you're going to replace it with a 3-ton and they're going to quote you accordingly. And so, explaining that you're looking at going to 2.5, then obviously your first cost of this replacement comes down. Beyond the actual equipment itself, the thermostat makes a big difference. Using a programmable thermostat, that's a requirement of virtually every green building certification system out there, is that you have a programmable thermostat so that you can set it according to your lifestyle. And I have a smart thermostat, so I also have the ability in the winter to leave my house for a couple hours and really ramp it down. And then whenever I know I'm headed home, I can control it from my phone and, turn the heat back on so that the house is where I want it to be whenever I get home. So that is even better than the programmable, that I can control it on the spot. And then the ductwork. So in a forced air system, the location of ductwork can make a big difference to the efficiency of the home, the efficiency of the system. So you mentioned, for example, in Florida, almost everybody has a super hot attic. That means that your building envelope is in the ceiling of whatever floor is below your attic, right? You've got insulation there, and then your attic is above that insulation. So it's outside of your building envelope. That's an absolutely terrible place to put HVAC equipment, outside of your building envelope, right? Especially in a cooling climate. So, telling that system to turn on and cool to 72 degrees, cool things down to 72 degrees before it starts pumping it into the rest of your house. It's very hard for the equipment to do that when the equipment and the ductwork is sitting in a 110 degree attic. So if a consumer is interested in even going to the effort of possibly, not necessarily moving the equipment, but redesigning their home to create an attic space that's part of that conditioned space. So taking that insulation that's in the ceiling of the rooms below and instead moving it up into the roof itself so that the volume of your attic is now part of your conditioned space. That's a consideration to help with efficiency of equipment. And then the other aspect of ductwork, particularly if it is outside of the building envelope, is the leakage rate of that ductwork. So if you've got a bunch of ducts in your really hot attic, not only are you telling the system you need to work really, really hard to get this air to 72 degrees before you pump it down into the house. Well, then if you've got a bunch of leakage, it works really, really hard to get to 72 degrees. And then let's say 10 or 15% of that air is going into your attic because it's leaking. It's not even going where you're trying to get it. So really paying attention, to the ducts that you can see, looking at them and seeing, are they sealed well? Do they have, tape? Or the better than tape is a product called mastic, which is really like a glue-like product that's painted on. So if you're looking at ductwork, looking at a home that has ductwork that looks like it's been painted at all of those joints, that's typically actually a better way to do it than that foil tape. That tape can tend to come off over time. Beyond those considerations, which are all mostly relative to forced air, heat pump or gas furnace, in the warming climates like where I live, a lot of people have a gas furnace and electric air conditioner, regardless of what which utility they're using. Everything I just talked about was mostly related to forced air ducted systems. The newer technology, at least in the United States, is to look at mini splits. So these are kind of similar to the old-fashioned window air conditioners that you put in your window. These are very specific, smaller units that are designed to heat and cool smaller spaces, similar to what you would see in a hotel. So, some of the pushback that comes from consumers is the aesthetics of these things. But again, if you're really focused on efficiency, mini split is a great option to be able to heat and cool smaller spaces, so that then you've got more control over how much you're heating and cooling different spaces. So again, you've got an upstairs that you're not in all day long. So now I can turn the upstairs system, tell the thermostat to keep the upstairs at 78 degrees for the day, because I'm not going to be up there. And I'm going to program the thermostat to cool it back down to 72, at 8 p.m., right before we're all getting ready to go to bed. But downstairs, I can control this to be at the temperature that I need it while I'm here today. And I will back up and say you can have zoned control of ducted systems as well. So again, if you're really getting into replacing your system altogether, or if you're building a new construction home, it is also possible to design dampers and controls that you can still have one main air handler unit, and all of your ductwork is still connected throughout the home, but you can have multiple thermostats that would open and close dampers and direct the air into particular areas, according to your lifestyle. So zoned control is not unique to a mini split, but it makes it a lot easier. It's a lot more obvious and less maintenance. So I've built, a lot of homes that have the zoned control dampers and forced air ducted systems. And of course, when we're getting back to the conversation of life cycle costs, those dampers are eventually going to break. They are a piece of mechanical equipment, and eventually, it's going to have to be either tweaked or replaced over time. So the mini split eliminates that consideration.
In terms of new technology, because I'm with you on mini splits. I mean, I love it. I just picture a new house it can't get more efficient because you're not moving air anywhere. It's just cooling or heating the air in the room.
Mhm.
And then I think of other things like if you have an Airbnb, I mean, it's like everybody can control their own temperature, or regular family. I mean,
Mhm.
to have everyone in every bedroom controlling their own temperature with a remote is amazing.
Yeah.
And then also now there's variable speed technology, I guess in all HVAC, but is it true that it's more efficient just to kind of keep something on, even if it's working at 10%,
Yeah.
constantly to adjust instead of cycling on and off?
Yes, it definitely is. And that is, to my knowledge, that is particularly important in a humid climate. So where you are in Florida, I'm in Pittsburgh, I'm in a humid climate. A lot of my career, we built in the mid-Atlantic, all in a mixed humid climate zone. And that is part of the comfort level comes with the dehumidification that happens with your HVAC system. So not only the cooling down of the air, but helping to draw the moisture out. And that is, so yes, having it run in a very low energy mode and just, to continue to provide that dehumidification versus the air conditioning itself, that can make a huge difference in comfort. You typically, and getting back to thermostats and then, the whole system in general, there are very sophisticated thermostats that will also give you the ability to control humidity level as well as temperature, if you've got the equipment to support that. So typically, if it's less humid, you're just as comfortable if the temperature is a couple degrees warmer. So we think it has to be 68 degrees in order for me to be comfortable, but 68 degrees at, 60% relative humidity feels a lot different than 68 degrees at 20% relative humidity. So yeah, the humidity plays a big part in HVAC, and you're exactly right that if you can opt for equipment that gives you the ability to run at those lower speeds and run continuously, that is definitely going to be better in the long run.
Does that also start getting into like the safety of living in a home with mold issues and things like that, if you can keep the humidity lower?
Absolutely. Yeah. Yeah. And so HVAC, a lot of people forget what the V represents. It's ventilation, right? It's heating, ventilation, and air conditioning. And ventilation is a big part of building science and a high performance home. So the catchphrase is build it tight, ventilate right. So again, when we talk about building it tight, which we've already talked about today, air sealing and making sure that we're keeping the air in, that we're heating and cooling and keeping the air out that we don't want. That also gets back to air quality, right? If you live in a place like I do in Pittsburgh that doesn't have the greatest outdoor air quality, that, again, you don't want all of that coming into your house. So we want to focus on building a tight envelope to make it more efficient, but then it becomes that much more important that a ventilation system is designed properly. So people create humidity. People create moisture. We're breathing. We've got plants in our homes. I've got 8 plants right here in this room behind me. We're running a clothes washer, a dishwasher. We are constantly putting humidity. We're taking showers. We're constantly putting humidity in our houses. And so the ventilation to get that humidity out of the house is a very critical part of exactly what you said, not just, efficiency, but health as well, to make sure that you're not trapping moisture and creating a health problem in the way of mold.
That's great. Yeah. And it's like you hear these stories about the mold and everything growing behind walls, and that's stuff you cannot see, but is happening and you're breathing it. And I've had friends of family actually die from, weird scenarios like that.
Wow.
And so it's just, who knew, right? The mold growing behind the drywall or whatever. Every time I take a wall apart here in Florida, there's some kind of mold back there on these older homes. I mean, vapor barrier, who knows about what happened there, but you find it all over.
Yeah, and it is. It's hard to identify. It's hard to know it's there until it is, a really big problem. just to kind of elaborate on, ventilation itself. So again, that's something that's going to be very unique to different climate zones and the way that the home, where the home is and how it needs to perform. So typical ventilation that you find in most homes is an exhaust fan in bathrooms and an exhaust fan in your kitchen. Again, these are requirements of any current third-party green building program. They're going to require that you have all of this ventilation installed. The building code has required ventilation in bathrooms for quite a while, but I'm pretty sure that the building code still does not absolutely require ventilation in the kitchen. That's still something that you can install, a recirculating vent hood. And that's not actually taking anything out, right? It's just recirculating it. So looking for a home that has, exhaust fans working, operable, actually doing their job. Exhaust fans makes a big difference. It's very easy to put it. I think that what I was taught is that if you can take a single ply piece of toilet paper and put it against the vent and it holds it, then you've got a 50 CFM fan operation, which is about the minimum of what you want at 50 CFM. If you can put a 2-ply piece of paper and it holds it up there, then you're getting closer to 75 or 100, which is really more ideal. So if you are turning a fan on and you hear it running, that isn't always a sign that it is actually doing its job. Putting that piece of toilet paper against it is a really easy test to make sure that it is actually sucking. And then a lot more sophisticated ventilation is going to come in the way of an ERV, an energy recovery ventilator. And then in cooling climate zones, that same technology is a heat recovery ventilator, HRV. There's a lot to be said for including those technologies in a new home. It would be, I would say, the average, home renovation project is probably typically not going to introduce those. They allow you to get that ventilation out, but then also be bringing air in as well. So again, really making sure that you're getting air changes in your house, that the air in your house is not just being recirculated and still and stagnant, but actually pushing it out and then bringing other air in and filtering that and, introducing new outside air to your house all the time. So ventilation is a big part of, people forget that what that V stands for when they're thinking about HVAC systems. And that V can really make a big difference in home performance.